Okay, let's work some classwork problems in trying to find appropriate correlation values for different types of data. For this classwork, we're going to work with the file ELS data_small, which I have open in JASP on the left. And let's just start with this first problem. We wish to explore the relationship between ninth grade reading achievement scores, English self-efficacy, and teacher-rated writing ability. All right. And so we know that achievement scores and self-efficacy and writing ability in this data set, they're all continuous variables. So from the get-go here, we are thinking this is probably going to be a Pearson correlation. So let's go to classical correlation, and we are going to put in our reading achievement scores, our English self-efficacy, and writing ability. And again, I'm thinking this is going to be Pearson's, but I know I need to check assumptions. I'm going to go ahead and do flag significant correlations. I'm going to do my scatter plot, and I'm going to do my Shapiro test for normality. All right, so let's take a look at JASP. And we see with scatter plots, with all the pairwise scatter plots, we see linearity, that we can most likely assume linear relationships between these variables. When I look at, so do scatter plots suggest we can assume a linear relationship? Yes, they do. All right, and we ran the correlation. And can we assume normality? All right, and then interpret a Pearson correlation. And we see here with Shapiro-Wilk that our p-value is 0.424, so we do not reject the null. So we can assume normality with these variables. All right, and so part D, interpret the correlation between English self-efficacy and ninth grade reading achievement. So English self-efficacy and reading achievement, we see a correlation of 0.311, and it is significant. So 0.3 is moderate and it's positive. So we would say there is a significant positive moderate correlation between ninth grade reading achievement and English self-efficacy. All right, interpret the correlation between teacher-rated writing ability and ninth grade reading achievement. So with writing ability and reading achievement, we see a correlation of 0.515, right, which is actually now a large effect. All right, and of course it's still positive. So there's a significant large positive correlation between teacher-rated writing ability and reading achievement. Do you find it interesting that writing ability is more strongly related to reading achievement than the student's own English self-efficacy? All right, let's take a look at question 2 here. We wish to explore the relationship between parents' education and parents' aspirations. All right, so parents' education is an ordinal variable from less than high school all the way through a PhD. And parents' aspirations is also an ordinal variable. It's their aspirations for their children, the educational aspirations for their children. And so similarly, it is also less than high school all the way to completing a PhD. So these are both ordinal variables. So given the fact they're both ordinal, what type of correlation is appropriate? And I'm hoping that you're saying Spearman is going to be appropriate here. So let's remove these variables. And now let's add parent education. And let's add parent aspiration. And again, these are ordinal, so we're going to check Spearman. We don't need to worry about normality now, but we do need to check for monotonicity. And it's a little hard to see here with this scatter plot, whether or not we have a monotonic relationship. So just to be safe, let's go over to descriptives. And let's put in parent aspirations and parent education. And let's do a scatter plot. And let's see. That is not what we're looking for. So here we do, unfortunately, the scatter plot with ELS data is hard because there's so many data points. And again, these are ordinal, right? So, we only have possible options up to 7 for the aspirations and up to 8 for the parent education. And so it's really hard to see because we're not seeing the density on these possible outcomes. But we are able to put a linear line on there. And again, we don't care so much about linearity, but it is telling us that we do likely have monotonicity or a steadily increasing function here. All right, so let's go back now to the correlation. All right, interpret the correlation between parents' education and parents' aspirations for their children. So we see this positive correlation of 0.228. Which is between 0.1 and 0.3, so it would be considered small. It is significant. So if we want to interpret it, we would simply say there is a significant small positive correlation between parents' education and the aspirations parents have for their children. Okay. All right, question 3. We wish to explore the relationship between race, ethnicity, and region of the U.S. For race ethnicity, we have 1 is white, 2 is black, 3 is Hispanic, and 4 is another race or ethnicity. And for region, we have 1 is Northeast, 2 is Midwest, 3 is South, and 4 is West. So what type of correlation is appropriate here? Well, these are clearly both nominal variables, correct? They are not ordinal, they are not continuous, they are names of things. And so we know we are going to need a chi-square test of association. So we go to our contingency table and we put in our race abbreviated variable and our region variable. And under statistics, we're going to go ahead and check also chi-square continuity correction and likelihood ratio. We're going to check contingency coefficient and phi and Kramer's V. Under cells, we're going to check expected. We're also going to check percentages for row and column. Okay, and let's take a look at these results. All right, so are the assumptions met? Well, they are both nominal variables. They have independent observations, meaning a person can only be in one race category in one region of the U.S. And if we look in our expected counts for all of our cells, we see every single expected count is larger than the number 5. So yes, our assumptions are met. Descriptively, what do you notice from the contingency table? Well, when we look at the contingency table, let's see. All right, so we see that we've got up here in region, we've got Northeast, Midwest, and South. So we are in the South. So let's just take a look here at maybe what is observed versus expected. So we see higher than expected numbers of white people. We see, lower than expected numbers of white people. We see higher than expected numbers of black people. Slightly lower numbers than expected of Hispanic people. And lastly, we see much lower than expected numbers of other race and ethnicity. So in this data set, that includes Native American, Pacific Islander, Asian, and more than one race. Okay, so that's just descriptively looking at our contingency table. All right, interpret the association between race, ethnicity, and region. All right, so we can look at our chi-square here because we do have a very large data set. So our chi-square is 774.681 with 9 degrees of freedom, and we get a p-value of less than 0.01. So this is telling us that there is a significant association between race, ethnicity, and region of the US. And then we want to interpret the strength of the association between race, ethnicity, and region. And here we want to look at Kramer's V as it is the most commonly interpreted. And we see 0.28 for 9 degrees of freedom. So we will need to interpret that. And typically when we see a Kramer's V between 0.1 and 0.3, we would refer to that as a weak association or small. So here we would say that while there is a significant association between race, ethnicity, and region of the US, it is a small association at only 0.227.